Hi, everybody. Welcome to Always Forward with dshaw. Today, we're going to do the first ever architect's view, and brought together a bevy of principal architects, and we're going to be talking about backends for front ends and kind of the future of that. We'll dive into a bit more of a definition of that and come back to that. But let me introduce the panel that's joining me today, and I'll start at the top of my screen and work around. So I'm joined today by Trevor Livingston. Introduce yourself, Trevor.
Hello. Oh, you say that. I thought you were going to introduce me. My name is Trevor Livingston, and I'm a principal architect at HomeAway, which is a vacation rental company recently acquired by Expedia.
And Ahmad Nassri.
Hi there, I'm Ahmad Nassri. I'm the principal architect at TELUS Digital. TELUS is a big telecommunication business in Canada, and I'm a fan of open source and a contributor to a number of open source projects. And my favorite language right now is Node.js.
And Jason Melo.
Hi everyone, Jason Melo here. I've been an architect, well, my whole career really, but the last 4+ years over at ADP. And most recently joined the team over at Nearform, focused on still kind of on enterprise architecture and the open source space in general. And yeah, +1 on Node.js and JavaScript. That's my my favorite camp to play in these days as well.
Excellent, excellent. So today, Always Forward with dshaw is brought to you by Node Summit and Operation Code. So thanks for supporting this, and it's great to not just get the dialogue out there, but one of the big things that I want to do with this show is get to know people and you'll also put a face to the voice, so folks get to know members of the Node community a little bit more closely. So backends for front ends, backends for front ends. As we were breaking down the monolith and beginning to adopt Node, was a really useful pattern. Who'd like to take and sort of define backends for front end? Ahmad, do you want to give it a shot of what that architectural pattern means?
Sure, I'll try to define my own view of it. Maybe it will differ, and maybe that's a good point of conversation. So backend for front end is a long-standing pattern of orchestrating and aggregating APIs and services for the benefit of the UI. Meaning that if you have a mobile device, as we all, I'm sure we do, they don't need to know about the complexity of your backend systems. Perhaps you have a long workflow or a process that you want to have a domain separation by design for how you want to make your data and your interactions work. But as far as the mobile device is concerned, or even a web application is concerned, the user just wants to press a button. So it's really to serve the customer experience and the user experience in terms of simplifying your backend complexity. So usually what you see is a middleware type of architecture where a server will sit in between your APIs and your UI, and you will actually put in some logic into the BFF layer, the server, that can call multiple APIs, orchestrate a number of calls, aggregate them together, and then perhaps do a bit of transformation to simplify the data a little bit. So if you really want to summarize it into 3 words, it's aggregation, orchestration, and transformation of data. Is that everybody's definition?
Yeah, I think that's a good definition. Anything that before I sort of meander off into like why that's useful. Anything that you'd like to add to that, Jason or Trevor?
I mean, for me, it certainly resonates with me. I think kind of that's been the way that we've looked at BFFs to date. I think there are a lot of kind of emerging patterns that actually kind of spread that out in a lot of interesting ways, which hopefully we get into in this discussion. But yeah, no, it certainly resonates.
So,
yeah, I agree. also one of the patterns I've seen with BFFs is that it is also often chosen as a pattern of how to share functionality between applications. So you have different UIs that may need to share common orchestration patterns, and often even if that orchestration isn't very complex, as opposed to sharing a code component, sometimes things will be shared through a service like a BFF.
Right on. So, Trevor, BFFs at PayPal, in moving from big monolithic Java application, pretty useful, right? Fairly functional solution to my goodness, there's this humongous bundle of Java. The fun little tidbit in that moment of time was 8 months to change a single, for CI/CD basically of, it's not very continuous, but the delivery chain of, getting a change, into just text, going out the door was 8 months at that time. So, useful approach when that's a that's your back end, and you need to move faster than deploying to that, right? That's a real salient moment of my goodness, you need some other technology solution to to get deployed bits out faster.
Yeah, and just kind of you mentioned PayPal, and that was missing from my introduction. Is prior to HomeAway, I was at PayPal and part of the Backend team that worked on replatforming PayPal to Node.js. Yes, we saw the BFF pattern. We at the time we were calling frontier services, and we saw those even in the kind of the fairly monolithic days of even C. And then as people replatform from C, C++ onto Java, when we had our services were actually proprietary in nature, we built a very, very large kind of orchestration layer in Java that was that reused a lot of the proprietary serialization, deserialization for those services, but it was actually proxied through Node.js, and unfortunately, just even having that just abstraction layer in general, even though it wasn't strictly a BFF, ended up in a thing that was almost impossible to end of life for 5 years, and it just when you have these kind of orchestration layers, whether it's something that's exposed directly to the front end, or even if it's something that is an orchestration layer for the back end of an application to interact with, what tends to happen is these things become very, very long-lived.
So that thing then becomes its own bit of legacy.
Absolutely. And one of the things that we've, and I'll get into this a little bit later in detail, but at HomeAway, many of these similar choices have been made to where to help accelerate replatforming, business logic and orchestration is shared by spinning up BFFs very rapidly and deploying those, and then having UIs interact with those directly. That's a kind of classical BFF model, and it does help accelerate some of that replatforming effort. But then you're left with it.
Mm-hmm. So Ahmad, you have some experience being left with a bunch of BFFs. You want to share the adventure of inheriting a whole ton of BFFs?
Yeah. So in similar sense, the inception at TELUS was to modernize our technology and modernize our stack, and just like the story of PayPal, I guess, that Trevor was mentioning, and as Jason pointed out, the whole benefit there is the shareability of the service, so that you don't have to duplicate your work and repeat yourself. But what happens at the scale of, like, our team is about 350 people now. Our community of practice, as I'd like to refer to our extended developer community that use our digital platform and tools, is around 2,000 people. So in terms of number of services, a number of APIs, a number of BFFs created, we're talking in the hundreds. And I think by last count, like I was just looking at our GitHub the other day, I think we're very close to 1,000 repository today. And you split that by 3 at least in terms of how many potential UIs there are and how many potential BFFs there are. What inevitably ended up happening was, over time, the pattern made sense, obviously, to modernize, but as Trevor pointed out, it in itself becomes technical debt, and it in itself becomes more work. But what happens is, because of that scale, like, shareability is more about, it starts with the culture than the tools. It doesn't really always get solved by the tools or by the technology pattern. So if people don't talk to each other, they inevitably will end up solving the same problem. And that means they end up having multiple BFFs doing the same thing. And we have that challenge today, whereas, in an ideal kind of architectural paradise, there will only ever be one BFF that does one thing, and then everybody can just use it. And it will only live for a short term, because, again, the principles here are, or at least the purpose that the journey we started with is to modernize our technology and our API backends, because we're talking about SOAP web services. We're not talking about RESTful services. We're not talking about any of those things. And as we like to refer to them as the systems of record in a telco business that you got to consider is basically 100 years old. A lot of these processes and transactions that have to do with the customer data and the kind of transactions you want to do on it were designed at least 20, 30 years ago, and just been legacy carried forward. So they don't really follow modern design principles. So the idea was to use the BFFs as an intermediary so that you can get to a better place with APIs, proper modern APIs. And then from there, you can start doing more fun and interesting things like GraphQL and HTTP2 and those kind of things to solve, again, the 3 things of aggregation, orchestration, and transformation. But at scale, it becomes a challenge because you can't all move at the same speed. You can't all move fast enough. And those BFFs themselves becomes a legacy layer of their own. So I'm sharing the same story, basically, but I'm just trying to put numbers behind it of why it is a problem. Because I would think for a smaller company, and I've been on both sides of it, like corporate or small businesses, it's an easy problem. You can say, okay, we have 20 APIs. We have 3, 4 BFFs. We might want to refactor them, modernize them, or just get rid of them altogether and use something even more modern. You can dedicate the time. You can spend 2-3 weeks and just refactor those things and update your applications. But when we're talking about the scale of hundreds of developers and hundreds of applications and thousands of community of users, that takes longer, unfortunately.
So, Jason, what about y'all at ADP? Did you get into a backend? Did you back into a backend for front end challenge, or was that something that was functional?
Is a little bit different. We were lucky in that kind of the group that I helped lead. We were essentially a greenfield organization, right? A very large one. We grew quickly. There's kind of 400, roughly 400 developers in that organization right now. So you definitely see kind of more of the traditional kind of pattern of abstracting or fronting backends across a large swath of other units at ADP. For us, it was more about, how do we cross domain boundaries when kind of new business use cases emerge, right? We were a microservices organization, a lot of kind of, separate kind of standalone domains that then came together to form the platform. And where we had those use cases where we said, look, we need to combine or aggregate data from separate sources. We need to do some transformations on that. We need to do some work on that data before extending it out for mobile or web or whatnot. That's where kind of the BFF and some further on patterns like around GraphQL and whatnot started to emerge to support that.
Right on. So, Trevor, you talked about the PayPal, But with HomeAway, you have a very at PayPal there's a monolith. With HomeAway, you have a very different different challenge, different infrastructure where there's lots of different solutions and bringing those together. Was there any real difference between how you were approaching the problem with solving a monolith and solving sort of a constellation of monoliths probably?
Yeah, so there's kind of it's a very different situation at HomeAway. The history is that HomeAway has a number of APIs that were fairly coarse-grained, CRUD-based APIs to interact with different entities in the system. And typically, when you interacted with, when you fetched some model, it was really very large. It contained a lot of the data that you didn't need for rendering applications. And at the time, the experience was being modernized into moving away from things like JSPs and into JavaScript. This is pre-Node days. So part of the way that was accelerated was by doing the kind of the classical approach of building a BFFs specifically just to create more UI-friendly models and provide some of that orchestration. So it was just a way of basically carving off the APIs that were needed for building experiences and defining those. And in a sense, it's actually a pretty useful step because it gets people into more of a mindset of thinking about how do we surface data to our experiences and giving people a little bit of better idea about how they want to do that as kind of a migration pattern away from monolithic APIs and into microservices. So it's kind of a pre-step to microservices in that sense. And then as Node.js has begun to become adopted, these applications that were previously just rendering, they were kind of, maybe not quite as monolithic as something like PayPal, but fairly monolithic in terms of it was a very large Java Spring application serving an experience. And then these experiences were interacting with these BFFs. Those have begun to get broken up into different distinct Node.js applications, which then are kind of faced with this choice of being able to either take advantage of the existing BFFs that exist out there or new microservices, which is another kind of migration effort that's underway to break up the monolithic APIs. So you have experience monoliths breaking up into distinct experiences served by Node.js, and then you have APIs that are being broken up into microservices at the same time. And what you have kind of left in the middle are these older BFFs that are that ultimately need to go away. So this it's a little bit of a different situation, but it's once more one of those the paradigms that is very similar to ones previously mentioned that we ultimately want to get away from because they continue to kind of explode. And they kind of made a little bit more sense from a Java perspective, where it's actually a lot harder to share some of that orchestration logic anyway. So if you had these different applications that needed to carve off a particular piece of data and then make it more appropriate for an experience, then that could easily be just done in code. But then sharing that code actually was a little bit more difficult than just shipping it as a service. As we move to a Node.js component-based model, it's a lot easier just to encapsulate all that interaction with those APIs, whether they're the monolithic APIs of the legacy or the new microservices, just encapsulate that orchestration logic and then ship that as an NPM module.
Got it. So I guess I wasn't quite understanding. So it was more challenging to distribute the Java logic than it was in Node, or was it the other way around?
Yes. Yeah. No. Just the part is once again part of that kind of that resharing story is that traditionally in Java and just a Spring application, it's harder to be able to just componentize something that is a an endpoint that is doing proxying or orchestration to some backend service and shaping that data and then returning a model. actually being able to slice that off and share it as a component that anybody can just drop in is very difficult. Whereas in Node, it's just piece of cake.
Okay.
I would actually I would highlight that factor because when the BFF pattern was first brought into the team where I am, and this is full disclosure, before I joined the team, I would have probably had different ideas about it. But the idea of we want to share services, not libraries, was actually quoted, and that was the line of, yeah, we don't like sharing libraries. Library sharing is bad. Mind you, this was pre-Node.js as well in terms of converting the team to Node.js. But that idea does come from a background and history of challenges with other languages, I would say, perhaps, and prior to the explosion of modularity and componentization as a accepted and desired approach to doing software development nowadays. Yeah, and the Java example is definitely a good one. Like, it's really hard to do that in Java, and maybe even so today. But yeah, like that's always been cited, and now it seems we're coming back a full circle and saying, no, we want to do more libraries, we want to build more components. So I'm not dismissing the fact that perhaps the history was hard, but again, I'm not certain it is the right answer to go back fully to libraries and components, because then you have different problems. Then you have versioning problems. Then you have update problems. And are all the applications up to date or not? I'm seeing that already with the plethora of applications and modules we have to keep up to date across all of our teams. But again, I think like everything in life, it's all about a balance. So there has to be a balance in between.
Yeah, everything in Spring was solved with using more inversion of control, and that interesting pattern. Moving from there to the shared module can be a lot saner, but there are definitely areas where that falls apart. And not owning it really becomes how much is the entire organization investing in inner source, right? That becomes the organizational challenge there. You're organizationally committing to the ongoing upkeep of somebody else's problem, and that's.
And simplifying these architectures, I mean, there is no one solution. It's a holistic solution. Part of the reason that the BFFs exist, maybe for sharing that part of that solved with componentization and that modularity. The other side of it, though, is regarding kind of orchestration and being able to reshape data, is really kind of goes back to what sort of services are we developing in the first place. Some of these legacy services may be monolithic, the data might not be right for the experience. But as we kind of get into microservices, making sure that API and service developers are actually thinking about stakeholders, particularly the experienced stakeholders, and the type of data that they're serving, simplifies that for experienced developers to the point where they may have this module that is resharing that orchestration, but it's not having to do as much work because the services are already kind of experience ready.
Right.
I think like that's a rabbit hole we can go into as well, like libraries and modularization. But I've seen it as well, like having done, like I spent the last 3.5 years in the API and services world and building API products and services. And the idea is that the API provider should and will be the owner and the provider of an SDK for their API. And all you have to do is just use the SDK. Does present its own set of challenges too, right? So again, going back to Dan's point about like inner sourcing, and then for the audience, if you don't know what that term means, it's basically open source inside the organization, meaning that everybody in the organization gets to contribute and being part of the maintenance of these projects and applications, and they can follow standard procedures like pull requests and so on, right? But then that's the thing, like, are we talking about library sharing in the context of the API provider or the API team in this context will create the quote unquote SDK and then people can use it? Or are you talking about the consumers can create a shared library based on their usage of their API, and therefore, an n number of teams can share the same functionality and cross-maintain that library for themselves?
Yeah, exactly. And I think regardless of kind of how you're approaching the creation of that, it's then embracing things like, the open communications that InterSource brings, the, talking about trade-offs and constraints, why do we do things one way versus another? Really kind of sharing all of that is how then your users can make those choices and say, yep, that fits my use case, or no, let me look at the patterns here, but I kind of need to implement this a little bit differently for me.
Cool. Well, I think that's a good sort of cutoff point, and I'll roll into our first little interstitial, and I'm going to go ahead and transition Jason and Ahmad off screen, and we'll get ready for Trevor. So our first little sponsor break is for Node Summit. This year, Node Summit is back in San Francisco at the convention center in Mission Bay. Great location. We spent most of the Node Summit time there. It'll be from July 23rd to 25th. And we have really exciting news that we're just confirming with some training providers that we're going to be adding 2 days to Node Summit for skill building and training. So July 26th and 27th, you'll have the opportunity to dive deep in skill building around Node, building good APIs. Building on modern JavaScript, using ES modules and some of the new capabilities of the language and the platform. So really excited to introduce over the past couple of years. The Node Summit is really renowned for the big story around Node, the PayPal, the Walmart story, the Netflix story. These big moments where Node has evolved. Last year we had Trevor sharing the HomeAway story and how the HomeAway has built an incredible design-led pipeline that enables the entire team to test and verify and have deliver a compelling experience leveraging JavaScript and Node.js. So that's been the hallmark of the Node Summit experience, coming together and really discussing the evolution of the state of the industry over the past couple of years. That this industry has evolved. We're in a much more mature point of evolution. The need to tell the story of why you would choose Node has shifted to how do we do Node well? How do we deliver that effectively at scale? And therefore the need for training, the need for skill building is more poignant. So really excited to bring that to Node Summit this year, and look forward to sharing that with everybody. So save the date, July 26th and 27th in San Francisco. Make it a week for Node.js, and come join us at Node Summit. All right. Myself out of there and get Trevor on the screen here. So Trevor had a kind of the impetus for getting this crew together comes from a really great blog post that Trevor wrote about BFFs and ripping them out and replacing them with better solutions that work better for the team. So I'm gonna hand things over to Trevor. We're gonna go deep into this story a bit, and then we'll come back and have a discussion around that. All right, Trevor, all yours.
Cool. Thank you, Dan. Can you see my screen, Dan?
Looks great.
Okay, great. Hey, so just kind of reintroducing myself. My name is Trevor Livingston, and I am a principal architect at HomeAway. I'm working on a platform, digital transformation. We're doing cloud migrations, breaking down monoliths. HomeAway is really kind of in a period of transition, really rebuilding its entire technology stack, top to bottom. And some of the kind of vision around that technology is kind of around being cloud-enabled, being global, having very being data-enabled. Means being first to know, and having deep kind of observability and insight into our systems and the sort of ways in which users are interacting with our system, and then continuous learning, which is really just kind of about experimentation and build, measure, learn principles. Right? It's about being able to bucket users into a particular experiment, test out a hypothesis, and determine kind of the next course of action. And there are a lot of challenges with this sort of massive effort around replatforming and globalization. We're coming from an old world of handlebar templates, Java, Spring applications, kind of the typical backbone based front ends, and that presents various challenges in the sense that it's typically lends itself to more monolithic applications. These applications tend to be difficult to insulate from change. These different shared orchestration layers, like BFFs, may affect multiple teams and an unknown number of components. When you have UI components, it requires context switching for developers. So if you are a full stack developer, then you're having to context switch between Java and JavaScript, and it's hard to share, as we mentioned earlier. It's difficult to do intersource well with some of these other stacks. There are various other problems, also continuous delivery. It's slow to evolve our technology. It's harder to adopt, and this day and age, things are just moving so fast. You need to be able to allow teams to adopt, and these monoliths make it harder to. Kind of more importantly, is the architecture that existed previously. So I touched on it a little bit before, but the previous architecture had evolved to having essentially what was a thin application that would do an initial render of a UI, and that UI would go back and interact with BFFs. Sometimes it would be proxied through the application, but that BFF would basically acted as a shared orchestration and business logic. It helped, do kind of model shaping or orchestration based on whether you were a native mobile user or you're a web user. And often this was kind of intended for reuse in general. But this paradigm introduced a lot of different problems. Typically, it's very difficult to manage these kind of things cross-organizationally. If you're one team and you're building something just for yourself, it's pretty easy. But once you start thinking about this as a shared API across multiple teams, then the different needs of those teams becomes fairly difficult to manage very quickly. Has typically unpredictable capacity requirements. If you are spinning one of these up and additional teams begin to use these BFFs, you need to take into account all of the stakeholders and your capacity needs and how much you need to scale that. As mentioned, it just adds an additional moving part that adds complexity to your architecture, and it can be a single point of failure. When one of these goes down or a bug is introduced, it may affect numerous different teams or applications, and as a result, it's difficult to predict those upstream effects. Who may have been affected by either a bug or a version change. And it's not as friendly for isomorphic applications as we move to more of a React isomorphic app model. These data interactions need to be able to be from a server-side renderer or a client-side renderer, and having this BFF in the picture that needs to be accounted for, because what you're exposing publicly versus as a on your primary domain versus something that may be an internal URL that you want to go through. So things like that. And then kind of just as mentioned, it's very difficult to detect actually as you version these APIs who may have been affected. So you need to be able to understand every single component that may be interacting with the service and what those upstream effects are going to be. So the executive summary to that is this kind of lovely, this could be a foot gun or in this case a face gun. It's basically results in what can be a mess, especially as you've built hundreds of these, and you're suddenly left with this legacy. So how about our new world? As I mentioned in our replatforming effort, we're moving to React-based UI backed by Node.js applications. We've begun to introduce GraphQL very heavily into our applications. We have modules. We're based on Happy.js, and that has a few benefits, immediate benefits, which are that we have more of a plugin-based architecture. We're flexible through configuration. These things make it easier to just reshare in general. There isn't as much need for that kind of resharing aspect of BFFs. It's very easy just to wrap something in a plugin and then share it between a couple different teams. It also allows us to insulate from change because we are going through the application now. As once an initial render occurs, these UI components will then talk back to the application, and that makes it easier for us to provides us less deployment complexity. There's less interdependence between teams because they're sharing libraries, and they may need to keep track of versions, but they do not need to necessarily coordinate service releases. It insulates us from change. So if something is if there is a downstream issue with the service or something else, then having that component be able to handle it at the application level and then gracefully degrade the experience for the user is a lot easier. It is you aren't dealing with a major difference between client side and server side rendering. If it's server side, you can directly interact with libraries. If it's the even better kind of model that we've moved to now is through GraphQL orchestration. So this really allows us to provide kind of a dead simple means of sharing orchestration logic. It's very composable and allows us to kind of mitigate those migration pains and insulate us even further from a very kind of rapidly changing API environment where we are breaking down monolithic APIs, building new APIs that are more microservice approaches, and then as those change, being able to mitigate it through GraphQL types and have those be less of a breaking change and more of just an evolution of that type. And when I mentioned kind of that simple, kind of self-orchestrating and composable applications, GraphQL is really nice in the sense that it allows us to encapsulate the fetching of data through GraphQL resolvers and types in a kind of in a reusable component itself. We have in this kind of application architecture an application that's exposing some GraphQL endpoint for the GraphQL server, and then a browser that is a React application that is interacting with it. But we can take basically a slice of this application and then componentize it into a separate component where you may have a partial representation of that GraphQL schema that is either shipped directly with a React component that is basically the data needs for that React component, or it could actually be separated into its own module as well that can be broken up as fine-grained as you like. And of course, all of these different GraphQL partials, as we call them, come together to form a single executable schema for your application to interact with. So you have a query that comes in and executes against that schema, and then each of those GraphQL partials may go interact with a different service under the covers, but to both the developer and the end user, that just happens, you know, for all intents and purposes, like magic. This has made it a lot easier for us to also accelerate our native mobile development, that as we break down what was previously kind of a monolithic BFF for native mobile, we can break that into different GraphQL partials and then share those partials across both the web experience and the native mobile experience. So they may have slightly different needs based on what their needs are, but they can choose between them and share them. So in a sense, this is almost like another type of BFF. It's just a kind of an evolution of that concept that is a lot more effective because it's shared through components. The way that this is kind of just an example of orchestrating those different pieces is that this is just kind of a code snippet of registering those different partials that we have a GraphQL server, and then just reference different modules, which represents a particular piece of our GraphQL schema. And you can kind of think of that schema as almost like the API surface that's being exposed. A GraphQL partial looks basically like this. It's just a collection of types and a collection of resolvers. And then finally, the kind of an example React component that's using one of these partials will basically look like this. It's just a very simple specification of the data that's needed for this component as a decorator on that component, and then the rest is just taken care of by what we use for the client is Apollo today, which is a really great GraphQL client. And I don't know how this will play over streaming, but this is just a little very short video kind of demonstrating what it's like as a developer to interact over GraphQL and interact with the data needs for this component. You'd seen the previous query at the top of that component are referenced in the HTML for the component or JSX. So that is very simple. You just modify the data you're asking for, and then you reference that data directly. And then just upon reloading and everything, it just updates very, very quickly. The other really kind of nice aspects of this is that each component can kind of declare its own query. And these queries will be kind of collected and merged and optimized, at render time, and those requests over the wire as a result are optimized as well. Instead of having to do multiple different AJAX calls, you can encapsulate many different data fetches within one request, and that will go resolve against all of them. And that's it for this this presentation. So I'll go ahead and stop sharing. Thank you.
Yeah, as Trevor was saying, that video is awesome. Yeah, that was fun. Nice to be able to to see that context of how it's used.
Yeah, and that's just been the one of the greatest things about this. This could be almost just like entirely a pitch for GraphQL, but just that change for the developer and interacting with data. That from a React developer's perspective, being able to just kind of declare the data that they need for that component is a huge change from having to go and make some RESTful HTTP call to some service and then parse that data back and then load it into their from there. It's just a lot cleaner. And everybody who's kind of made that transition at first, GraphQL seems very daunting for developers, and they hear about it and go, oh, I'm not sure, I don't have any experience with that, and we've kind of continued to tell them that, oh, it's really simple, just give it a try, check this out. We give them some materials, and as soon as they make that transition, it's rapidly accelerated them because it's just so much easier to deal with the data needs.
Are we coupling our presentation with our data too much though there?
There's a lot of different ways in which you can separate this as much as you like. At the end of the day, these components need some sort of data, and often these are shared components that are fully fully interactive. If you take the example of something like a login form or something like a date picker, those will have some sort of backend data that they need to interact with, and when sharing them across teams, having that tightly coupled to the data for kind of the end-to-end integration testing is fairly useful. But that's really kind of up to the developer at the end of the day if they want to couple it closely like that or if they want to separate it.
Got it. So you could just return the data and have some other indirection or some other service in the middle.
Exactly. Yeah, and also GraphQL clients like Apollo are pretty nice in the sense that they can integrate with things like Redux as well. So if you wanted that data to happen as part of Redux actions, then you could do that instead of kind of declaring it on the component itself.
Got it. So Ahmad and Jason, just off the cuff, that outcome, kind of goes BFF services to GraphQL. Do you all agree? I know, isn't it cool?
Go ahead, Ahmad.
I was gonna say, I do have that UI to data coupling challenge that I haven't gotten over yet. But the way I would get myself over it is by thinking of the React layer not as the UI, but as the thing that generates the UI. And therefore, it does make sense to have a little bit of a data association there. What I don't know, though, is there are other challenges beyond sharing or sharing logic or sharing UIs or sharing anything that BFFs tend to help with. So specifically when we talk about orchestration and aggregation, part of that aggregation mostly is GraphQL solving that. Orchestration, maybe. So what I mean by orchestration is when you have, let's say, a checkout flow and the customer just wants to say, here's my credit card information, buy. You might have a domain system that does the fraud detection separately from a domain system, or a microservice that does their credit check qualifier separate from a microservice that does your actual billing. And that's a process. You have to go through all three steps to do that. And if one fails, you want to potentially do different things. We still haven't solved that problem. So we still need BFFs for those. GraphQL is not necessarily going to get you there, or the kind of patterns that we're talking about here are not going to help solve that challenge. And then there is the, orchestration, aggregation, and transformation. So transformation is definitely something solved in that coupling in the context of GraphQL and or the UI to data coupling. Then you don't have to deal with transformation as much because as as Trevor showed, like you can make that coupling work to your benefit.
I mean, one of the things I love about GraphQL is that it has a fairly unopinionated take on how it resolves requests. So whether that's a mutation or a query, it's just calling a function, and that function you can have as complex orchestration as you like, right? You need to think it through, but in your payment example, you can still go and orchestrate however you like, and then but from the developer, kind of the experienced developer's perspective, it just seems like they're resolving a query, right? And so it really kind of that thinking still needs to kind of come into play about the types of problems that we need to solve, and how that solves gets kind of changed into GraphQL resolvers versus a kind of a typical REST endpoint, and preferably we get into a world of where our microservices are rich enough to where orchestrating against those with resolver is actually very easy, where you can make a couple different calls in parallel and then and kind of be done with it. But that's kind of why I mentioned earlier that this needs to be a holistic approach. You can't just say, well, GraphQL solves all the problems, or componentization solves all the problems. Is that we have to think about what we want the customer experience to be and what we want the developer experience to be, and then design towards those.
Right. Yeah, absolutely. It's like the hammer and nail problem, right? It's we're not just carrying hammers and everything. It's not just nails. So we have to look at the whole kind of toolbox. There's a couple of things too where kind of this progression starts to make a lot of sense, especially in organizations where you don't have a lot of ability to kind of affect change on the upstream. Your kind of backend systems and whatnot. A lot of kind of the traditional BFF approach, there were a lot more kind of asks or constraints in kind of the relationship between those aspects. So it does allow you to kind of run faster, have a lot more velocity with saying, okay, I need to kind of scope my data a little bit differently. I need to look at different use cases and provide those for different clients. GraphQL, it is nice in kind of the whole additive schema approach. If you do take that approach and kind of versionless APIs and whatnot, so it's definitely kind of it is kind of solving more things. But totally agree with both Ahmad and Trevor, where it's like it's certainly not a solve all. It's but there are a lot of benefits. Another benefit that comes up too, where kind of where a BFF would not necessarily scale to, is where we see a lot of these kind of emerging edge opportunities, right? I know Cloudflare just today, I think, went GA with their workers, the basically V8 workers that can live out on the edges and whatnot, and all of that can be driven by different, whether it's kind of, Lambda interactions or other kinds of, serverless patterns that you want to come in that are event driven. You can bring a lot of what you're doing in GraphQL either directly or indirectly from a pattern perspective to those use cases. So it's much more on kind of the progression of modern cloud architecture, whereas BFF is starting to get a little bit orthogonal to that.
Mm-hmm. Mm-hmm. So I want to dive into functions as a service in a second, but let me take our final sponsor break here, and we'll come back and have that discussion. All right. So the next sponsor on our docket is Operation Code. So Operation Code is a group that serves our U.S. military and family, and the folks around our veteran community by helping provide skill building and enablement for folks coming out of service and family members to level up from the skills that they would be interacting with in in the military, but won't necessarily be using all of the latest buzzwords. So come with robust experience and really fantastic skills to apply to the workforce. Don't necessarily have all of the buzzes that we just heard: GraphQL, React, and Node.js. All those things may not have been the technologies that they were working in those battlefield situations. So taking those skill sets, by working with boot camps and other accelerators to help apply GI Bill resources and enable our nation's veterans to be effective and to really enter the workforce. So this year, I am the co-chair of the Operation Gala Dinner and Dance. This will be the second year of that gala, and I invite you to join me on November 10th. This will be kind of a big sort of soiree smoothie thing. I've been told I have to dress up nice, and we're going fairly formal this year. So if you have a department that supports our veterans, I'd love to have a chat with you and have you join me. Some folks from Nike and Intel and IBM joined me last year at the Operation Code Gala, and we had a fantastic time there. Getting together, hearing about the stories and the evolution of Operation Code, and supporting that together. So November 10th, I hope you'll save the date and join me in supporting Operation Code. All right. So get Ahmad and Trevor and Jason back. And talk a bit about functions as a service and how that is changing this dynamic. So Trevor, why don't you kick that off? Because at least as far as I know, you've gone the deepest into functions as a service and aggregating that as an enabler for your teams.
Well, it's more of a dream, let us say, than a reality today. Is that we're kind of in the midst of a breaking down the API monoliths for microservices. Really, those microservices are I saw somebody introduce a new kind of term of nanoservice, because microservices have kind of started to be used as a term to describe just what I've historically thought of as a regular service, right? It's like, here's a Swagger REST API for interacting with some collections of data, and that's a microservice because it doesn't have the whole world, so it's therefore micro. And I like to think of microservices as single operations, right? Is that you are doing a thing, and that's all. And that kind of harkens back to that kind of the Node.js way of do one thing and do it well. I really kind of feel like that's how kind of microservices should operate as well. And that's why things like functions as a service are a really nice way of thinking about microservices, is because you kind of have to think of these as single operations. And you can kind of plug these into APIs that you expose. If you look at kind of Amazon's API gateway, they allow you to specify kind of a Swagger API, and those APIs may be backed by different lambdas, for example, and just execute different functions. So it seems like a REST API, but it's actually backed by single operations, single operation microservices behind the scenes.
Mm-hmm.
Kind of next evolutionary step that I really see here is that, as we start kind of going to a kind of a more kind of a naturalistic and kind of natural and declarative way of interacting with data through things like GraphQL at the edge, you might have API consumers. If you ever use GitHub's GraphQL API, or you have different experiences and React applications that are interacting with GraphQL. Once it comes into the system, the future that I'm trying to work towards is that that doesn't interact actually with the API, but what it emits an event in the system. And when that event emits that event, you can have these different operations, or something else that is actually listening for those events and then responding to them. So if you imagine a company saying, the user at the end of the day is really saying, like, I want a beer. Right? Then there's a robot bartender operation that is saying, I make beer. Here's a beer. And you're connecting the developers who are developing the business logic to the needs of the customer much more readily. And this allows you also to do things like, event sourcing a lot easier. So I do think that that's the future, is that we will start taking those steps to actually breaking down these complex API specifications and eventually arriving at these very distinct operations that are operating on an event mesh.
Yeah, I think that conceptually and orchestrated by a system that is managed internally by the organization, that sounds interesting. As you push things into Cloudflare doing a thing, and you've got like 10 layers of indirection in your API. That someone put something at the edge that we're not orchestrating or conceptualizing together. The Cloudflare instance is the one that sort of unless it's an emergency failover kind of a scenario where Cloudflare is beginning to take over. When something in the internal layer is failing, that definitely concerns me.
Yeah, I think it's a similar phenomenon to say like IoT or whatnot, right? It's just that you have a lot more these distributed compute runtimes, and the ability to not have to re-envision them over and over again, right? You take V8 is like this great ubiquitous runtime. You're starting to find it in all of these places. I think that's one of the big benefits. But back to what Trevor was touching on, is to say, I like that term he used, the event mesh. And if you embrace this, event-driven approach, some of those problems, Dan, that you're pointing out, like, okay, I have these 10 different layers of different indirection and abstraction, and I can't really reason with all of this. Mm-hmm. If events are your first-class construct, and you drive things through that, then it's very discoverable, and it's very easy to plug into that and componentize that out. And that's especially where something like fast and serverless comes in, because, okay, great, now I have an ability, a unit of functional compute that I can also key and trigger off of these events.
Is the pattern there also repeatable? Like, if you start talking about serverless and functions as a service and all that, you'll inevitably end up stuck with the same pattern of nanoservice, microservice, and UIs that also need to be orchestrated. So you have this, I use the word mesh in a different way. You have this mesh of interconnecting and cross-connecting data points to serve your UIs, right?
Mm-hmm.
Yeah, I mean I think the problem that exists in most of these fast systems today, whether it's Lambda or OpenWhisk or what have you, is they're based on the premise of executing a function, but there's no composability. So, or composability is at least more difficult. But if we could get to a world where these single operations can be composed together, if we look at whether it's the Akka's actor model or even something like Seneca.js, which has a really interesting model, you get this, composability of functions, and it also makes it easier to version functions. So you could start basically surfacing a kind of a system of record or source of truth for specific types, and then for your business needs within a particular domain, and then surface those through things like GraphQL. And when you do that, then you don't necessarily end up with this kind of spaghetti mess. It may seem like a spaghetti of chaos from a bird's eye view, but as you zoom in, it becomes highly ordered. But it's just highly ordered by those individual domains. I think that's kind of the missing element that we're kind of in today, is that we've started to evolve towards serverless and fast, but we haven't introduced kind of those concepts that we learned from things like functional programming, is having the true composability of those different functions.
Sorry, Jason. I was gonna transition over to one of the questions, and let me just pull this up because I think we can dive deeper as we answer this question. So the question from Bill Lee is, how do you keep your GraphQL types backward compatible for different API versions and major changes?
Yeah. So I guess my I made a comment, but my question there is if it's the I guess if it's the downstream API that the GraphQL resolver is calling, or if it's the kind of GraphQL type version that you're talking about. I kind of suspect it's the former. And just in general is one can hope that any kind of major change to an API is going to result in a major version change, and that resolver won't necessarily be calling the new version. But because GraphQL, kind of the one of the principles is kind of this evolution of the API without breaking changes. It's kind of a versionless API. If you do want to move to that new version because maybe version 1 is end of life and you need to get to version 2, you can solve that through introduction of things like type resolvers, right? So if you want to maintain kind of the same, serving the same type, but you have an entirely different underlying data model, your resolver and your types can evolve to do that.
Yeah, that's a model we use. Am I getting echo?
More of just a little bit of breakup.
So the ability to go and most APIs lived forever, and this is pre-GraphQL. But those endpoints, we would eventually have serving the new data, but shaped back into the old API format. So that's how we end up resolving that. And it sounds like there's some good opportunities in GraphQL to keep that consistent. That's great. So Jagesh Chandra asks, what process do you follow to manage GraphQL schema changes across all the partials?
So I think that regardless if you're talking about GraphQL or really anything else, when you start talking about types, when those types become shared, it requires some sort of governance. So what we want to get a lot better at is being very good about governing and having some sort of central repository of our types or type definitions when it comes to kind of core domain model. And then and those are the typically the kind of the shared types. And then when it gets into kind of some particular team and they built a partial, they have various types there, then it's kind of really more up to them. But getting better about being able to centralize our type definitions, and that may be even something other than GraphQL that we generate GraphQL types from, allows us to have better governance over kind of those types that we're using. And then when it kind of comes to managing that change across, for the schema, when we introduce changes to those basic types, it kind of goes back to that same kind of principle of the evolution of the API. Is you should be able to add new fields, fairly easily without necessarily versioning, and then deprecate old fields, and provide proper messaging around those. And then if those are all broken into different modules, each of those partials, then it just becomes semantic versioning as part of the NPM package.
Yeah.
But I mean, this is definitely an area where requires additional thought. We've gotten to a certain point. We need to get a lot further along that as we scale, because that's the complexity is once somebody mentioned, I don't remember which of you it was, but mentioned having kind of the SDK clients, right? It's kind of a similar situation as you ship all of these out there, and then they explode, and you have hundreds of them or thousands of them. And then managing that complexity can be very difficult and needs to be thought about. It's a good question.
Yeah.
One of the things, just briefly, that really helped us out, or just kind of starting to toy with it, but putting it in practice, is around semantic versioning, but leveraging NPM itself and into our own Artifactory, and giving developers the ability to pull those in, and just following the practices of semantic versioning. What do minor versions mean? What do major versions mean? And then having either tilde or caret, kind of prefixes to manage those dependencies in the code base.
I want to play the devil's advocate here. At what point does the GraphQL layer becomes the monolith layer?
Everything can quickly become your monolithic layer if not done right. Yeah.
Yeah. I think that part of the reason that we took the approach that we did was that GraphQL doesn't, typically when you make a schema, you'll make that schema for your application, then you have to go define all the resolvers, you have to go interact with things, and it's kind of it's a one-off. And it kind of harkens back to, framework development versus application development. When you develop an application, it's really easy, but you want to scale that application's, similar type of development across an organization predictably requires some sort of, tooling or framework. That's part of the emphasis behind actually taking the concept of GraphQL schema and then breaking it into these partials that may be a collection of just a piece of that, they represent only a piece of that schema, and then be able to kind of plug and play those in based on the application's need into a single schema. In that sense, you don't really have a monolith because each application is basically orchestrating for its own needs. It says, I need type A, B, C. Another says, I need only B and C, or somebody else says I need D and E. And each of those are their own kind of components, and then they become a single schema for that app. Where I think you do wind up with the potential for a monolith is especially is around GraphQL API development. So if you're actually replacing your API with GraphQL, but then you tend to be making this kind of ever growing massive schema to execute against. And that's where, you might wind up with that kind of the next version of a monolith, right? And you do probably have to think about how you actually break that up.
I think one of the caveats in your, sorry, go ahead.
Go ahead.
I was just saying one of the caveats in your statement is agreed as long as you keep your resolvers thin and just wrappers around endpoints.
Yeah, preferably.
Because you can, like you said, like GraphQL is not opinionated about those functions, and you could literally just build business logic there. So that should be the caveat in that design.
Yeah, I want to bring in Renee Parra's question about Netflix because it touches on this. So Netflix, for example, grew out of a monolithic API. Then they moved to an internal API with an abstraction layer. Groovy on top of that. Anyone know what they're doing today? Well, I have good news, and you will not be surprised by the solution. So they moved Groovy to a Node.js based solution to largely a GraphQL API. So that monolithic API is differently shaped, but it's very much that choke point in the stack where in our old monoliths the data abstraction really kind of database at a certain level and then like hibernate and the ORM, is really where, that was anchored. You kind of moved a little bit out of the database. But this choke point of the API as the source of truth, I think is a better choke point for the type of applications that we're building today. But as Ahmad points out, that there are tons of foot guns here that we can go and pave in logic and expectations into the system that are not extensible, not don't give us the opportunity to grow and evolve that over time if we're hard coding too much of that at the edge.
Right. I'm not sure how kind of prevalent it is internally for them, but they have a competing framework and standard for this, right? In Falcor. The competitor to GraphQL in a way.
Right. Yeah. Sorry. I gloss over them as yes, all of that is GraphQL, and you're right. It's not. So where are folks going with GraphQL? We REST APIs have kind of become passé. No one wants to really deal with REST that much anymore. But REST had a lot of pragmatic, long-term approaches to the data evolution, right? The whole HADOS principle, where the API would tell you where you could get the data. And Ahmad, you could probably describe this way better than I could. This is your jam, Ahmad. What's this API tier going to look like in a year from now?
Well, let's just highlight the fact that HADOS starts with hate.
The clever thing about REST that nobody used, right?
Well, yeah, I think the principle is sound. Then you get into the craziness of all these specs and standards that end up trying to implement the idea of hypermedia, and you end up basically having developers quit and go become lumberjacks. Because the complexity that it produces is actually way more harmful than the value it could produce. And again, I'm talking in larger scheme. I'm sure it works for some folks and some teams and some APIs, but I don't think it is the answer. I don't think it's the approach. And the reason I say that is because the fundamental idea there is that you're describing, just for the audience, the hate OAS. Stands for hypermedia as the engine of application state. Yes. Which is basically the idea is that, using hypermedia annotation on top of your data, you can describe what your data is and what your interactions with your API looks like, so that humans don't have to be the ones to define those interactions, but machines can read it, right? And the idea is that we're writing code, so code can do this for us. So I can tell my code that, oh, here's my API, here's the entry point. Oh, and by the way, all the interactions are already described in the API, so just figure it out on your own. But the missing part in all of that is that we have to teach the machine of how to figure that part out. So of course there are libraries and tools, but then it just becomes a heavy burden of integration effort, as opposed to, if you think of the developer experiences, I need to make a screen or I need to make an interaction with an application. I just need to tell the data or grab the data or do something on the server. So the over indexing on the integration part and teaching your application how to interact with it becomes one of the biggest pain points. But again, I will go back and say, like, the principle of hypermedia does make sense because it's baked into the dissertation about the HTTP standard by Roy Fielding from the start. So it is baked into the internet. It's baked into the web. It's baked into all our modern technology as a foundation. I just don't think the hypermedia technology and tooling that implement that on top of RESTful APIs have been vastly successful.
Yeah, I'd say, just to add to that is that I wouldn't kind of label REST or Helios as something passe or dead or whatnot. I think it's just quite different, right? REST is really about a system describing what it is providing, as opposed to you look at something like GraphQL, which is a recognition of the emerging use cases and what you want to do with that data. That's I think one of the key differences for me, and where there still is a place for REST, but I don't think that REST has the legs to support all use cases of a modern application and platform.
Yeah, I think my other problem with REST is kind of coming from we're going through the same thing here at HomeAway, but at PayPal, we did a big transformation to first, I think it was Google Discovery documents for API specification, and then eventually Swagger, which is now Open API. And yeah, it's really easy for somebody to craft a really elegant API and describe it with something like Swagger once, right?
Right. I was waiting for the once, right?
but getting that to scale is extraordinarily expensive. Mm-hmm. And what we need to be looking for today is killing the need for API specifications. How do we provide value without incurring the cost of specifying APIs in this way, right? And I think that's kind of the hurdle that things like Open API specification and other API specifications are going to have to deal with, because they don't scale.
Mm-hmm.
I would say, just full disclosure here, I used to be on the Open API initiative board, and I will take some of that blame as well. Yeah, like my past was in the API world, and like I was working for a company called Mashape. You've probably heard of it. Now called Kong for some reason. There's a logo over there.
Perfect.
Yeah, we build API products and services. Yeah, I think what I've noticed, having been, this is going back, I think 5 years now, like being in, and you got to consider the time frame. 5 years ago, everybody was still battling with, and to be honest, still is, like I am today in TELUS with a big corporation, still battling with like SOA architectures and web services and WS Death Stars and like, if anybody has never heard of the web services world and the WS schemas and standards, just go look it up, and then you'll immediately get a nice hair that's all gray overnight. But within the span of my tenure at Mashape, I'll give you I think it was 3.5 years. Within 3.5 years, the conversation went from RESTful APIs and HateOS and hypermedia and all of that to microservices, to immediately functions as a service. And I think the one lesson I would share from that is the industry has evolved so fast because none of those things worked.
Mm-hmm.
Right? So a lot of investment went into hypermedia and RESTful API designs and tooling and applications. They did solve problems. They were good. I still love them. I love RESTful API design and domain-driven design and all these things. But it doesn't scale. And it doesn't scale not on the technology level. It doesn't scale on the human level. And the same thing with microservices. Microservices became a big thing. And now we're talking beyond virtualization. We're talking about containerization. We keep trying to iterate. And that's a good thing. So we're solving these problems in faster iterations. But the proof is in people don't talk about hypermedia anymore today. People don't talk about RESTful APIs today. Everybody's more interested in, as Jason just articulated, and the different type of views on the problem is rather than solve the problem for the system, solve the problem for the human or for the use case. So I think that's where we're seeing that disconnect nowadays with things like RESTful services and hypermedia and microservices. They're all great. They all solve a problem, but they don't solve my problem as a developer who needs to interact with these APIs.
Yeah. And, I agree that this has been a continuous evolution because nothing is working. The way I like to think of it is that we all come from this kind of old kind of programming perspective of, I've got some data, I need to wrap it up in a box and provide it to somebody. and I'm going to create some sort of input to that box and some sort of output from that box. And that's my my formal definition of how to interact with the system. Whereas I think the problem that we need to be solving for is connecting end users with what they want, right? They're asking something, and we're telling them how to ask for it. What we need to get better at is allowing them to ask for it how they want to ask for it, and that being represented by some sort of event, right? That you say you need something or you want to do something, and we can respond to it more flexibly. And I think that that's something that we can get better at governing the formal side of that, just at the very outer edge with those interactions, and worry a lot less about having to, do formal governance internally.
Great. Well, why don't we let Trevor have the last word here? And it's been a fantastic discussion. It sounds like we've made progress. We haven't found that silver bullet yet. Keep on searching for that. The one true way of encapsulating and delivering experiences faster and better. And we'll continue butchering the pronunciation of whatever we create next.
And hey, it's the job of a principal architect to search for silver bullets, but never to quite find them. Because then we'd be out of a job.
Yes. It's why if you call it a utopia, the actual definition of the word utopia is fantastic, because it's a place that you can never really kind of arrive at or attain, but you're always in search for it. So I think that applies here.
Oh man. Thank you, Trevor. Thank you, Ahmad. Thank you, Jason, for joining me today. It's been a real pleasure. I like to wrap up with plugs. So if there's anything that you'd like to plug or promote, please feel free. Trevor, I'll start with you.
Nothing in particular. Just please use HomeAway for your next vacation.
Awesome. Jason?
Just if you need any help in your organization moving towards, kind of GraphQL and serverless and all the things we've been talking about today, just wanted to plug great folks at Nearform.
Awesome. Ahmad?
I will plug a community that I run called Tech Masters. It's over 5,000 developers and technologists from around the world. We talk about these things all the time. Do join. We also run conferences and events. We are running the Functions 2018 conference in Toronto. So that will be talking about functions as a service. So you're all invited. So join the community so you'll get more announcement about Functions conference and other conferences as well.
Excellent. So thanks again.
The website, techmasters.chat. It's easy.
Techmasters.chat. In the chat, you will probably see that URL show up in the chat eventually. Smooth transition. Thanks again to Node Summit and Operation Code. And we'll see you all next month. Thanks, everybody.
Thank you.